this is Dan Powell. I'm a scientific officer with the Centre for Genetics, Ecology and Physiology at the University of the Sunshine Coast in Queensland, Australia. I work mainly on genomics and shellfish, and for my doctoral studies, in partnership with researchers from Macquarie Uni and the New South Wales Department of Primary Industries, we formed a consortium to sequence the genome of the Sydney Rock Oyster. The Sydney Rock Oyster, it's from the genus Sarcostria, and it's endemic to Australia and New Zealand. And like the more common Pacific oyster, it's considered a delicacy in restaurants around the world. It's also quite an economically important species for aquaculture here in Australia, where we've had a rather long-standing commercial industry. So one of the main reasons for sequencing the genome is to provide a platform to help the farming industry move towards a whole genome selection. But apart from the advantages for selective breeding that you get from having a genome, we're also interested in some of the molecular mechanisms that might be involved with important traits such as disease resistance, time to market, and also reproductive performance. And for oysters, these mechanisms are not that well understood. So among the invertebrate genome sequenced so far, oysters are known for high levels of heterozygosity and also high levels of repetitiveness, which we're seeing with this genome as well. This makes them difficult to scaffold and leaves you with quite a fragmented assembly. Other groups have sequenced phosmid libraries to try and overcome this in the past. So for this oyster genome, which we think is about 1 gigabase in size, we developed a draft that was with about 120x coverage of Illumina small insert paired end libraries and a few mate pair libraries that gave us around a 70 kb N50 and around 70,000 scaffolds. The largest mate pair library we had was about 10 kb, but we still had rather a fragmented assembly. So we got in touch with Dovetail and sent a sample of tissue all the way from here in Australia over to California, and they were able to extract some high molecular weight DNA. The Chicago library was run just on one lane of HiSeq, and after the high-rise scaffolding, we managed to get the equivalent, or perhaps even a little bit better assembly metrics than those of the previously published oyster genomes. The scaffold number dropped down to 12,000, and the N50 lifted up to 680 kb, and this is without the need for phosmids or long-read sequencing. The whole process took just under a month, which was great, and Dovetail were fantastic at providing progress updates along the way. The high degree of continuity we now have with the Dovetail scaffolding allows us to really go in and look at how the gene content is organised throughout the genome and identify promoters and other upstream regulatory elements that may have roles in controlling things like growth rates or spawning. And we can, of course, also look at the structural differences between the other oyster genomes. So we're really happy with the result, and we'll definitely look to apply Dovetail scaffolding in our future genome projects.